In this video, I'll look at shadows of angular forms, and it's in my book, Ellen's Guide to Casting Shadows on Amazon. For this upright floating triangle, we have light rays going through its peak and shadow lines going through its base, but they don't meet. So how do we find this shadow? You set up poles where we see the top of the pole and the end of its shadow, and that will give us these two intersections here. And we can set up other light triangles here to get these two intersections, and that gives us the lines of the shadow. Now for this pyramid, start again with the light going from the apex down to the casting surface. And we know it's the casting surface because it meets this middle line through the center of the form. And then the shadow goes to either side of the pyramid. For this last one, pretend as if the wall isn't there, so we know the direction of the shadow where it meets the light. And then when it crosses the wall, just have it go up to intersect with the light. To find the shadow of this upside down pyramid, we would have to find seats and then light triangles to identify the intersections. And the pyramid touches its shadow if the tip of the pyramid is on the ground. To find the shadow of this hexagonal prism, we would just use these vertical poles and with light triangles identify the intersections. And if we rounded this out, then we could also round this out and we would have the shadow of a cylinder. When a leaning form is uniform, like this ruler, we can't find the light direction. But if it's not uniform like this knife, then we can use various points like this point here to find points on the shadow. For objects leaning against the wall, the diagonal shadow here makes the wall look diagonal rather than vertical. But if you put in lines and textures on the wall, it helps allay that impression and makes the shadow appear transparent. When drawing shadows of ladders, one of the challenges is determining which rung goes with which shadow. So start at one end, as I did here, and then march up the ladder, finding the light direction. And you can see here that the light direction is parallel, so the shadows are also parallel. This shadow direction goes underneath the ladder and is headed downward. And if this were sunlight outside, the shadow direction would either be horizontal or upward. It would never be downward because it has to go to eye level. Now, where is eye level in this picture? Well, we see the bottom of this ladder and we see the top of this rung. So eye level, I'd say, is somewhere around here, where the step looks like a line. So our shadow vanishing point is below eye level. That means this must be artificial light because the shadow direction is going down and the shadow vanishing point is not on eye level. For this table, the shadow direction goes like this and it intersects the light at this green dot. Then it converges with the horizontal pole. Similarly, for this light triangle, the shadow direction is this way and it intersects the light right here, and then it converges with this horizontal pole. For the triangle on top, we can extend the table and the shadow direction to find point 3, and that will give us the shadow on the table. How do we find the shadow of this little triangle? One way to do it is to convert it to a shape that we have already studied, which is a horizontal rectangle. Then give them seats and draw the light triangles so that we can get these two intersections. The shadow lines follow the lines of the rectangle, and when they hit the wall, they go to both back ends of the rectangle. And then you just cut off this part of the shadow because we're just getting the shadow of the triangle. Of these two tables, I think you would agree that this is the less interesting of the two because it's in one point perspective with true vertical and horizontal lines, and because this initial shadow direction is horizontal, although in the back it becomes more diagonal like that. This table is in 2-point perspective with only true vertical lines and no true horizontal lines, and it has a shadow direction that's slanted upward like this. For this cross, we first have to get the vanishing point for the cross, and that indicates where eye level is located. The light is above it, and the shadow vanishing point is below. So this must be artificial light because outside, the shadow vanishing point would be on eye level below the light right here. Then we need to just keep our lines and numbers straight. So for example, shadow direction 4 here can be used for points 6, 7, 10, and 11. And you can see that the intersections here are 6, 7, 10, and 11. Please remember to subscribe and take a look at my book on Amazon, Ellen's Guide to Casting Shadows.